All right, so this lesson is all about the classification of matter. And you've already looked through a few of the text resources, just some of them, but we're going to talk a little bit more in depth about how we classify matter. We've been talking a lot about the particle theory of matter, changes of state. So now let's classify some things here. So to begin, matter in general is anything that has mass and volume. So anything that has mass and occupies space. Okay? Basically, anything that's made of atoms. And this is what matter is. Okay? So what we're going to do is that we're going to divide this into two sections, and you can see this division line here. There's pure substances on the one side, and so that's this over here, and we're going to talk about those. But then also mixtures, okay? And mixtures are not pure substances, they're also known as impure substances, okay? So an impure substance is a mixture, and pure substances, so this is a good division. All right, so what we can do with impure substances, those over here, and you'll notice that we've got ways that we can purify impure substances. We can separate them by physical means, okay? So we can distill, we can filter, we can use settling, we could use a magnet, and these are the ways physically that we can separate impure substances. Okay, so let's talk about mixtures, and we're going to go through here and kind of fill in this note as we go. Okay, so when we're talking about impure substances, what this means is it means that we have more than one substance. Okay, so a mixture is more than one substance. It may have several. The way that you can think about this is anything that has more than one ingredient. Okay, and this also could mean more than one particle type. All right, so that's kind of the definition. And if that's a mixture, then a pure substance then would have only one substance made of one type of particle. And the particle theory of matter tells us that in a pure substance, all the particles are identical. Okay? So an impure substance has a lot of different things, a lot of different ingredients. A pure substance has only one. Okay? When it comes to a change of state, so a melting point or a boiling point, and you can see that here, that's the example that's given, melting point or boiling point. A pure substance has a melting point and a boiling point at one temperature. And we call that a fixed point. Okay, so there's one temperature that a pure substance will boil at. There's a one temperature that a pure substance will melt at. That's a little bit different than a mixture. It has many different boiling points because it's made of many different substances. Okay, so it does not have a fixed point. It has many different things. So seawater, which is impure water, it's got all kinds of salt in it, it has a freezing point, but it's got a range, -5 to +3, okay? And the wider the range, the less pure the substance is, okay? So that's something to remember. All right, so moving on, if we want to separate, right, just like we talked about up here, to purify basically means to separate. Pure substances can't be separated, okay? So this is important to remember. A pure substance like water cannot be separated, okay? Can't by physical means. So we can't take water, which we know is H2O, and there's no physical way. We can't use a magnet, we can't use a filter, we can't use boiling, we can't use settling. We can't separate it into hydrogen and oxygen, okay? However, a mixture, we can. We can use physical means. So, for example, if you have sand and water, right, we could filter the sand, water, and water mixture okay, using filter paper. Or one of the ways that we see distillation is when we have crude oil and it's distilled into all kinds of different fuels, and one of those fuels is gasoline. Okay, so gasoline comes from crude oil, but when it's crude oil, it's all mixed in together in this mixture, this impure substance, and we can distill crude oil and we can get gasoline. And then there's a whole bunch of other things that we can get too, but this is one of the things. So this up here, this little chart that we've just created, talks about the number of substances that are involved. It talks about the changes of state that we'd see in fixed points, and it talks about how and if we can separate these substances into different parts, okay? We're going to stop our conversation of mixtures here, and now we're going to focus in a little bit more on pure substances and how they're further divided, okay? And we can see right away that pure substances, following the flow chart, are divided into elements and compounds, okay? We're going to talk about elements first. We're going to talk about compounds next. But elements have the distinct property that all particles in an element are identical, okay? And they contain only one type of atom. And that's really important. That's what makes them a pure substance. And so what we have is a little example here where we've got gold, and we've used this example before. So let's stick with it. So we've got a sample of gold, right, with gold atoms, and one of these golds is AU, okay, the symbol. And something else that we have is, say, carbon, right? And we've got a chunk of carbon, and this would be one carbon is, of course, C, one carbon atom, okay? And here, this would be the chemical formula for diamond, right? If it's in this shape, the chemical formula would be C, and this over here would be 24 karat pure gold, and the formula for that is AU, okay? So over here, the thing that this is one gold, this is an atom, right? So each one of these individual things is an atom, right? And each of these individual things here, this is one carbon atom, okay? And they come together to make things like 24 karat gold or graphite or diamond, whatever, Okay, so most of the elements that we see right here, most are made of identical atoms. Okay, so most elements are made of identical atoms. Okay, so they're all exactly the same. There's a couple different far out element examples, okay, which are a little bit different, and they're different, which makes them awesome. Okay, so let's talk about these. We've mentioned them before. So here's nitrogen, and remember that nitrogen is one of those diatomic molecules, right? So nitrogen exists together with a buddy. Okay, so this is pure nitrogen, and its formula, we remember that nitrogen triple bond from our ecology unit. This is N2. Oxygen, very, very similar, is a diatomic, and it's found in its pure form, its pure elemental form. You notice that we're still calling these elements. This is O2. Pure oxygen is found in a diatomic form. And although that there's 2 atoms per molecule, both are identical and therefore are still classified as an element. Okay, still classified as an element. The diatomic elements, we've already talked about them, but let's recap. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay, so those are the diatomic molecules. We need to know those. There's another really, really cool one. This would be one oxygen atom. There's another cool one. It's ozone. And ozone, this is one ozone atom, okay, or a molecule. And its formula is O3. And this is even rarer, right? This is a 3-atom triatomic element, okay? So this would be, I said that this was an atom and an atom. This is actually a molecule, right? Molecule. And this would be an oxygen molecule. And even though it's a molecule, because it's 2 things together, we still call it an element, okay? So those are the far out ones. So let's take a look at the periodic table now, because the periodic table kind of tells us where these things are, okay, and what these things are. So anything on the periodic table, you'll notice in one of our first, on our very, very first day, I gave you a periodic table. And on that periodic table, there's a big black zigzag line. Anything that's to the left of that zigzag line is a metal. And you'll remember that from hunting the elements, okay? So the metals are all to the left of the zigzag lines. Anything that's to the right of the zigzag lines are things that we call non-metals, right? So those are things that are either liquid or sorry, not liquid or gas. They're things that are not classified as metal, okay? And anything that kind of runs adjacent to that zigzag line are things that, well, sometimes they have the property of metals, sometimes they have the property of non-metals. Those things we call metalloids, okay? And so they kind of have properties of both. So this kind of looks at elements and kind of, you know, explains the element part of what we're going to talk about. Let's look at the other part of pure substances. Remember, we said we were going to divide pure substances into 2 bits, elements and compounds. And here we have the compounds. Still, though, all of these particles are identical because this is still a pure substance. But they're compounds, right? But each particle doesn't have just one type of atom. It has now 2 different types of atoms or more, okay? So different atoms though, and this is important, they're chemically combined, right? So they're not physically combined, They're chemically combined. So a really good example of this is water. Okay, so this would be H2O, and we've kind of talked about H2O before. And the reason we call it H2O is that it has two hydrogens okay, and one oxygen. Two hydrogen and one oxygen. Okay, and that's what's involved in this. So as we go down the list, let's take a look at a couple other ones. This one right here is one of the most common. This is NaCl. And this, some of you will remember, this is table salt. Okay, so we call it sodium chloride. Its name is table salt, but it has the name sodium chloride. Okay, and its formula is NaCl, and this would be one salt molecule. Okay, so this right here would be one salt molecule. All right, and the last one is table sugar, and this one we present because it's kind of interesting. So table sugar, it's got the chemical name glucose, or sorry, sucrose actually. Sucrose is the chemical name for table sugar, and here's its formula: C12H22O11. So it's got a ton of different atoms in it, right? You can see there's 12 carbons, there's 22 hydrogens, there's 11 oxygens. This would be a sucrose molecule, okay? And so these are all compounds, right? You can kind of see sucrose right here. These are much bigger molecules than salt or water, but they're still compounds and they're still considered pure substances, okay? So that is how we classify matter, and from now on we can start talking about pure substances and mixtures, but specifically elements and compounds.